Okay, so in this video I'm going to show you what the cast rule is. So on your page what I'd like you to do is draw out what you see in front of you here, what I've drawn. So it's the Cartesian plane. I've labeled all four quadrants and I've drawn the terminal arm that extends from the origin all the way up to a point that I've labeled xy. The radius, that's why we use r. I'm going to show you how this is going to form a circle. This length is 1. The angle that we don't know here is theta. We have this 90-degree angle drawn if I extend the height down with this point here. So the first thing what I want you to do is realize that if this point is xy, this bottom part of the triangle can actually be expressed in terms of sine, cos, or tan. So think about this for a second. Sine theta is going to be equal to the opposite. Well, what's the opposite? It's y over hypotenuse. Now, whenever we divide by 1, it's really redundant. We don't need to divide by 1 because we're going to end up with the value itself. So y is actually equal to sine theta. Next, let's do cos theta. Cos theta is going to be x. X over 1. I'm not going to write the 1. You don't need to. X is equal to cos theta. And finally, tan of theta, opposite over adjacent, y over x. So have a look at those three ratios. It doesn't matter where this arm extends. Think about this arm as being able to swing this way and this way. Right? As long as it doesn't pass this 90-degree marker here, then any angle that's in quadrant 1 is going to have this ratio. Sine theta is y, cos theta is x, tan theta is y over x. In other words, we can state that all three of these ratios are going to be positive in quadrant 1. So that we know for sure. Well, what about the other three quadrants? We have quadrant 2, 3, and 4. Well, let's look one at a time here. I'm going to scroll down my page. Look at quadrant 2. Draw an angle just like I have in quadrant number 2. So again, this has been rotated from the initial arm all the way to here. Right? So this is the principal angle. This is the related angle. Usually, I'm going to put theta in here to represent that obtuse principal angle. Well, now let's look at the three ratios again and see what happens. Draw a triangle down. Always draw your 90-degree angle triangle. And let's label things. Now, the bottom here, this is the negative side of the x-axis. So that's going to be negative x. This terminal arm is still 1. The height is y. So now let's state those three ratios again and see what happens. Sine of theta is now going to be y over 1. It's the same thing as what we had above. The cos of theta is going to be negative x over 1, but again we don't need to write that. And tan theta is going to equal opposite over adjacent. So now look at what happens. Look at the signs of those three ratios. In quadrant number 2, sine is positive, cos is negative, tan is negative. So the only one that's positive is sine. We'll come back to that in just a sec. You can see that there. Now, let's look at quadrant 3. Next one. Do the same thing. Draw your terminal arm in quadrant number 3. Show me the principal angle. So this time we've rotated all the way around here. Now think about how these angles work. Here's 0 degrees, here's 90 degrees, here's 180 degrees over on the left side, and at the bottom we're going to have 270 degrees. If we go all the way around in a circle, obviously we have 360 degrees. So let's set up our triangle again. Draw your height. This time we have negative x we have negative y, because we're going down here on the y-axis, and this radius length is still 1. Sine of theta is going to be negative y. Cos of theta is going to be negative x. Tan theta is going to be opposite over adjacent, because again, there's that angle we're looking at. It's always going to be the angle that you make in your triangle. If we go back up here for a second, the principal angle theta is here, but when we're writing these ratios, you want to place yourself in the position of that angle. So in this case, tan theta, opposite over adjacent, negative y over negative x. Well, two negatives will cancel out, and you're going to end up with a positive. So, conclusion, in quadrant number 3, the only ratio that is positive is tan. Sine and cos are both negative. That's quadrant 3. Let's finish this off now. Quadrant number 4. Well, what I'd like you to do is draw your angle the way I have here, your terminal arm. Notice that we've swung this all the way around here. Draw your triangle. Again, here's your principal angle theta. The related angle, think of theta here if you will. It'll make things easier for you. Negative y, this is positive x, and here's 1. Now let's do this. Sine theta is negative y. Cos theta is positive x. Tan theta, opposite over adjacent, negative y over x. Well, what do we have here? The only ratio that is positive is cos. Okay. So take a look at what we've written out here. In each quadrant, there are some ratios that are positive and some that are negative. The only quadrant that has all three of them positive is quadrant number 1. All three are positive. In quadrant 2, only sine is positive. In quadrant 3, only tan is positive. And in quadrant 4, only cos is positive. Now there's a trick that we use to help us remember what all of this means, and it's called the cast rule. So as a summary, what you can do is just sketch out a plane. And you're going to spell the word cast starting with quadrant 4, C-A-S-T. What does this mean? Well, in quadrant number 4, C represents cos. That means cos is positive in quadrant 4. A stands for all. And put all. Cos. All three ratios are positive in quadrant 1. If we go over to quadrant number 2, S stands for sine. Sine is positive. If we go to quadrant 3, T stands for tan. Tan is positive in quadrant number 3. So it's a little trick we can use to help us remember where we're going to draw angles. You just need to remember where to put the big letters here. These tell you which ratios are positive in what quadrants. So here's our goal. You're going to go back to the page and read some examples as to how we're going to use the cast rule. Ultimately, what I'd like you to be able to do is to take any angle, say theta equals 210 degrees. Well, how are you going to draw 210 degrees? Well, you make a sketch. Now think of yourself here. That can be extended down. Here's 180 degrees. 210 degrees, we can estimate it's going to be somewhere here. Right? If we start here, we're rotating all the way around until we get to 210 degrees. I want you to evaluate this ratio. So in this quadrant, you got to think, okay, quadrant number 3. Only tan is going to be positive in this quadrant. So you're going to draw out your triangle. There's 90 degrees. And with a little bit more information, you're going to be able to solve for me this angle right here. I'm going to put a theta there. Okay? If you know this angle, well then we can simply add it to 180 degrees to get this full angle here. We already know it's 210 degrees. So knowing this as a sort of a preamble, go back to the page, read some examples, and I'll show you how to put the cast rule to work.